The National Electrical Code, or NEC, does not explicitly mandate that bathroom ground fault circuit interrupters, or GFCIs, be on a dedicated 20-amp circuit. However, NEC Article 210.8A3 requires that all GFCI protected outlets serving bathrooms be on a circuit separate from circuits supplying a minimum of 30 amps of load. This effectively limits the total load in the bathroom circuit to 20 amps, as the GFCI itself is rated for 20 amps maximum. As for smoke alarms and arc fault circuit interrupters, or AFCIs, the NEC does not specifically require smoke alarms in bedrooms to be on arc fault circuit interrupters. However, it does permit other receptacle outlets outside of bedrooms to be connected to the same AFCI circuit as the smoke alarms located in the bedrooms. Specifically, NEC Section 210.12. These states dwelling units shall have all 120 volts, single-phase, 15 and 20 ampere receptacle outlets installed in habitable rooms installed on a circuit protected by a listed arc fault circuit interrupter. To summarize, bathroom GFCIs are not required to be on a dedicated 20 amp circuit, but they are effectively limited to a 20 amp load due to the GFCI rating. Smoke alarms in bedrooms do not necessarily have to be on AFCIs. Other receptacle outlets located outside of bedrooms can be connected to the same AFCI circuit that protects the smoke alarms in bedrooms. For further clarification, let's break down each of these points in more detail. Firstly, concerning bathroom GFCI circuits, it's important to understand the purpose of a GFCI. A GFCI is a safety device designed to protect people from electrical shock. It works by monitoring the current flowing into and out of a circuit. If there is a difference of even a few milliamps, the GFCI will trip, quickly cutting off power to this circuit. This is especially important in bathrooms, where the risk of electric shock is higher due to the presence of water. While the NEC doesn't explicitly say the bathroom GFCI must be on its own dedicated 20 amp circuit, the requirement to isolate it from circuits supplying a minimum of 30 amps of load achieves a similar goal. This ensures that the bathroom circuit is not overloaded by other appliances or devices, which could reduce the effectiveness of the GFCI protection. Think of it this way: if a bathroom circuit is sharing a high load with other devices, a ground fault may not be detected quickly enough to prevent an injury. By limiting the bathroom circuit's load, the GFCI can react more quickly and effectively. It's also important to check local codes and amendments, as some jurisdictions may have stricter requirements than the NEC. These local codes might indeed require a dedicated 20 amp circuit for bathroom GFCIs. Secondly, let's discuss smoke alarms and arc fault circuit interrupters. An AFCI is another type of safety device, but it's designed to protect against fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating a spark that can ignite nearby materials. AFCIs are particularly important in bedrooms, where people are often sleeping and may not be able to react quickly to a fire. While the NEC doesn't mandate that smoke alarms in bedrooms be on AFCI-protected circuits, it's generally a good practice to do so. This provides an extra layer of safety and can help to prevent fires caused by faulty wiring or damaged appliances. Keep in mind that smoke alarms are life safety devices, and any measure that can improve their reliability and effectiveness is worth considering. Now, concerning the allowance for other receptacle outlets outside of bedrooms to be connected to the same AFCI circuit as the smoke alarms, this is permitted under specific conditions. The key is that the AFCI must be listed and suitable for protecting both receptacle outlets and smoke alarms. This ensures that the AFCI will trip in the event of an arcing fault, regardless of whether the fault occurs in a receptacle outlet or a smoke alarm. It is also essential to consider the load and the circuit. If too many receptacle outlets are connected to the same AFCI circuit as the smoke alarms, it could increase the risk of nuisance tripping. This is when the AFCI trips for no apparent reason, which can be disruptive and potentially dangerous if it disables the smoke alarms. To avoid nuisance tripping, it's important to carefully calculate the load in the circuit and ensure that it doesn't exceed the capacity of the AFCI. Finally, keep in mind that electrical codes are constantly evolving to improve safety and reflect new technologies. It's crucial to stay up to date on the latest requirements and best practices. This can involve taking continuing education courses, attending industry conferences, and regularly reviewing the NEC and any local amendments. Also, when working with electrical systems, it is always recommended to consult with a qualified and licensed electrician. They can provide expert advice and ensure that all work is done safely and in accordance with the applicable codes. In addition, understanding the difference between GFCI and AFCI protection is important. GFCIs protect against ground faults, which are electrical leaks to ground, while AFCIs protect against arc faults, which are dangerous electrical arcs that can cause fires. Both types of protection are essential for ensuring electrical safety in residential buildings. Ground faults can occur when electricity flows through an unintended path to ground, such as through a person touching a faulty appliance. This can result in a dangerous electrical shock. GFCIs detect these ground faults and quickly cut off power to the circuit, preventing serious injury or death. Arc faults, on the other hand, are caused by damaged or deteriorated wiring, loose connections, or other electrical problems. These arc faults can generate intense heat and sparks, which can ignite nearby combustible materials and start a fire. AFCIs detect these arc faults and quickly cut off power to the circuit, preventing a fire from starting. In summary, both GFCIs and AFCIs play a critical role in protecting people and property from electrical hazards. It's also a good practice to regularly test GFCIs and AFCIs to ensure they are functioning properly. GFCIs should be tested monthly by pressing the test button on the device. AFCIs should be tested annually by pressing the test button on the circuit breaker. If a GFCI or AFCI fails to trip when tested, it should be replaced immediately. Moreover, consider the specific requirements for smoke alarm placement and interconnection. The NEC and local building codes specify the required locations for smoke alarms in residential buildings. Generally, smoke alarms are required in every bedroom, outside each sleeping area, and on every level of the dwelling. Interconnection of smoke alarms is also typically required, meaning that when one smoke alarm sounds, all of the smoke alarms in the dwelling will sound. This ensures that occupants are alerted to a fire, regardless of where they are in the building. There are two main types of smoke alarms: ionization and photoelectric. Ionization smoke alarms are generally more responsive to flaming fires, while photoelectric smoke alarms are generally more responsive to smoldering fires. It's recommended to install both types of smoke alarms in a dwelling to provide the best protection against all types of fires. When selecting smoke alarms, look for models that are listed by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. These listings indicate that the smoke alarms have been tested and meet certain safety standards. In addition to smoke alarms, carbon monoxide detectors are also essential for protecting occupants from the dangers of carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be produced by malfunctioning appliances, such as furnaces, water heaters, and stoves. Carbon monoxide detectors should be installed on every level of the dwelling and outside each sleeping area. When selecting carbon monoxide detectors, look for models that are listed by a recognized testing laboratory. It's also important to consider the proper wiring methods for electrical circuits in residential buildings. The NEC specifies the acceptable wiring methods for different types of circuits and applications. Common wiring methods include non-metallic sheath cable, or ROMICs, and electrical metallic tubing, or EMT. Non-metallic sheath cable is commonly used for general-purpose wiring in residential buildings. It consists of two or more insulated conductors enclosed in a non-metallic jacket. Electrical metallic tubing is a rigid metal conduit that is used to protect electrical conductors. It is often used in areas where the wiring is exposed to physical damage. When installing electrical wiring, it is important to follow all of the NEC requirements and best practices. This includes properly sizing the conductors, using the correct fittings and connectors, and grounding the electrical system. Improperly installed wiring can create a fire hazard or electrical shock hazard. It is also a good idea to label all of the electrical circuits in the electrical panel. This will make it easier to identify the circuits in the future and can help prevent accidental shutdowns. The labels should clearly indicate the purpose of each circuit, such as lighting, receptacles, or appliances. In addition to the NEC, there may be other codes and standards that apply to electrical installations in residential buildings. These codes and standards may be adopted by state or local governments and can vary depending on the location. It is important to be aware of all of the applicable codes and standards before starting any electrical work. For example, some jurisdictions may require that all new residential buildings be equipped with arc fault circuit interrupters for all 120 volts, single-phase, 15 and 20 ampere branch circuits. This is a stricter requirement than the NEC, which only requires AFCI protection for certain circuits. In conclusion, electrical safety is a critical aspect of residential building design and construction. By following the NEC requirements, best practices, and all of the applicable codes and standards, it is possible to create safe and reliable electrical systems that protect people and property from electrical hazards. Remember to consult with a qualified and licensed electrician for any electrical work to ensure that it is done safely and in compliance with all applicable codes. Continuing education and staying up to date on the latest electrical codes and technologies are essential for anyone involved in the electrical industry. This helps to ensure that electrical work is done safely and efficiently. Therefore, it is important to prioritize ongoing training and professional development to stay informed and competent in this field. The NEC is updated every 3 years, so it's important to stay current with the latest edition. Changes are made to reflect new technologies, address safety concerns, and improve the clarity and usability of the code. Reviewing the NEC regularly and understanding the updates can help electricians, contractors, and inspectors stay informed about the best practices in the industry. Participating in workshops and seminars offered by electrical organizations and trade associations is a great way to learn about the NEC and other relevant topics. These events often feature expert speakers and hands-on training sessions, providing valuable insights and practical skills. Subscribing to industry publications and online resources can also help you stay informed about new products, technologies, and code changes. These resources often provide in-depth articles, technical guides, and product reviews, keeping you up to date on the latest trends and innovations. In addition to formal training and education, networking with other professionals in the electrical industry can be a valuable way to learn and share knowledge. Attending industry events, joining professional organizations, and participating in online forums can provide opportunities to connect with colleagues, exchange ideas, and learn from their experiences. Electrical codes and standards are constantly evolving to reflect new technologies, address emerging safety concerns, and improve the performance and reliability of electrical systems. Staying up to date on these changes is essential for ensuring the safety and efficiency of electrical installations. Continuous learning and professional development are essential for anyone involved in the electrical industry. By staying informed, participating in training programs, and networking with other professionals, you can ensure that you have the knowledge and skills necessary to provide safe, reliable, and compliant electrical services. As technology advances, electrical systems are becoming more complex and sophisticated. This requires electricians and other electrical professionals to have a deeper understanding of electrical theory, control systems, and data communications. Investing in training and education in these areas can enhance your skills and open up new career opportunities. For example, the growing popularity of smart home technology has created a demand for electricians who are knowledgeable about home automation systems, networking protocols, and cybersecurity. By acquiring these skills, you can position yourself as a leader in the field and provide valuable services to your customers. In addition, the increasing focus on energy efficiency and sustainability has created a demand for electricians who are knowledgeable about energy-efficient lighting, renewable energy systems, and smart grid technologies. By investing in training and education in these areas, you can contribute to a more sustainable future and help your customers save money on their energy bills. Moreover, consider understanding load calculations. Load calculations are an essential part of electrical design and are used to determine the size of the electrical service, feeders, and branch circuits. The NEC provides detailed guidelines for performing load calculations, taking into account factors such as the size and type of building, the appliances and equipment to be used, and the diversity of the load. Accurate load calculations are critical for ensuring that the electrical system is adequate to meet the demands of the building and that it is safe and reliable. Performing load calculations requires a thorough understanding of electrical theory, the NEC, and the characteristics of electrical equipment. It is also important to consider the future needs of the building and to allow for future expansion. Moreover, consider that proper grounding and bonding are also critical for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. Bonding connects all of the metal parts of the electrical system together, creating a low impedance path for fault current. Proper grounding and bonding are essential for preventing electrical shock hazards and for minimizing the risk of fire. The NEC provides detailed requirements for grounding and bonding, covering topics such as the size and type of grounding conductors, the location of ground rods, and the methods for bonding metal enclosures. It is important to follow these requirements carefully to ensure the safety of the electrical system. The NEC and other electrical codes and standards are constantly evolving to reflect new technologies, address emerging safety concerns, and improve the performance and reliability of electrical systems. Staying up to date on these changes is essential for ensuring the safety and efficiency of electrical installations. Continuous learning and professional development are essential for anyone involved in the electrical industry. By staying informed, participating in training programs, and networking with other professionals, you can ensure that you have the knowledge and skills necessary to provide safe, reliable, and compliant electrical services.